Hello, my calculus people. Today we're going to do some notes on limit definition derivative. This goes with the worksheet you got right here. And basically what we're going to learn is a more official way of finding the slope of another function at any point. Now we did that kind of a trick way by squeezing in with a graph and doing some algebra trickery to kind of do that. We're going to get a more formal way to do it. So, a function that describes the slope of another function at any point is called a derivative. This is a word we're going to use like a million times. Derivatives are like half of what calculus is about. So if you want an equation that finds a slope at any point along the line, it's called a derivative. We had you remember that equation from 3.0 where this starts off with a slope that's negative, right? And then it really flattens out, it's less negative. And it's a positive slope, then it's really steep, right? There's an equation for that. So if this is the graph of the original, then the slope at any point was represented by 2x, if you remember. There's a symbol for that. It's y prime. It has a little mark. If this is y, then the slope of every point can be found by using this. This guy right here is called the derivative because it is a function that could find the slope of any point on this graph. It's pretty cool. It has lots of applications in real life. Like you can find the instantaneous speed of something if you have a distance graph. You can find the acceleration. You can do like any rate of change you have. It's basically using derivatives. So it's used a lot in physics. That's why there's a calculus-based physics. But we have this new word called derivative. In your brain, you need to know the word derivative means a function that can find the slope at any point of another function. Now, the way we come up with it, to come up with this function, also known as the derivative. So in order to come up with a derivative, the process is called differentiation. Kind of a different term for that in education. AKA to take a derivative. So you will find sometimes my directions will say find the derivative. Other times my directions will say differentiate or use differentiation. All right, so now for the big formula. This is the formula we're going to use. This is the limit definition of derivative. That's why we learned limits first, because our real goal is to learn about derivatives. But we had to learn limits first because our definition is f prime of x. That means, once again, it's called prime. It's really a little apostrophe. If this is y equals x squared, then this guy called y prime equals 2x is the derivative, or it's the slope of that graph at any point you want. So this would be the derivative. You call it f prime. I'll put that in quotes here. F prime of x is how you'd pronounce that. Equals the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. Now this looks crazy. This is the This is the formula you're going to use on every problem. It looks crazy, but it is nothing more than y minus y over x minus x. That's what's crazy. It is a fancy way of saying slope at any point. So if you think about this, imagine I had this graph. If I called this point x, y, and I called, or not x, y, let's call it x, and then f of x is the y part, then what if I picked a point really, really close to it, and it's just a tiny bit further than x, maybe x plus a tiny amount, which is called delta x. What would the y be? F of x plus delta x. So if you look at this, if these are my 2 points that are super duper close, and you have to imagine them closer than that, I would take y2 minus y1 over x2 minus x1. What do you get when you take x plus delta x minus an x? You get just delta x. So it really is slope. But if I take that delta x to 0, it means my points aren't even that far away. They squeeze, squeeze, squeeze until they're a single point. And that's what a derivative is. Now, there's notation for this. There's a few different ways you can name these. I've already showed you y prime and f prime. So there's this for a derivative. You could call it f prime of x, right? You could do this, y prime. There's another way. This is more like directions, dy over dx, which you should recognize from our table where we did delta y over delta x. And if you were to say this one, you would say differentiate y with respect to x. It still means slope, change in y over change in x, right? And there's one last way you may see it. We'll see it like this too. This more or less tells you to take the derivative of that guy with respect to x. It's the same exact quote as this one. Differentiate with respect to x. Both of these say the same thing. So anyway, whenever you see a little prime or this dy dx, it is talking about the instantaneous slope, a graph that could find the slope at any point, which is a powerful thing. So let's actually do one of these and see how it works. All right, so here's our first example. If this is our function, f of x equals x squared minus 1, it's just a parabola, I want you to differentiate this equation with respect to x. And I want you to use the limit definition of derivative. So basically, we're going to, over and over again, plug whatever darn equation they give us into the limit definition of derivative, which we just wrote down in a box, but it's worth writing down again. Every time, you should start your problem like this. F of x plus delta x minus f of x over delta x. This is the formula. Okay. Now I'm going to start plugging in stuff to make it match this guy. Okay. So the first thing I like to do, well, you have to have your limit as delta x goes to 0. First thing I'm going to do is deal with this guy. So if this is regular f of x, I want to write f of x plus delta x. And if you're wondering what the heck you do, well, let me do a little thing off to the side real quick. You don't have to write this down, but just go with me on it. If that's my equation, I asked you for f of 2. What would you do with that? You would go 2 squared plus 1, right? And you get 5. If I said, what's f of negative 3? Well, I'd go negative 3 squared. Oh, why did I do plus 1? Oh, geez, rookie. That was minus 1, so it's 3. Negative 3 minus 1. I'm following this equation. Oh, negative 3 squared is 9. 9 minus 1 is 8, right? What if I said f of triangle? Not that you would, but right? I just want you to get the point that anything I put in parentheses here, I will put in for x, and I write the rest of the equation. Okay, that brings me to here. So if you ask me to do f of x plus delta x, I'm going to take this guy, and I'm going to put it in just for x. Now I still have the minus 1, so don't get crazy here. I'm going to do this, f plus delta x, or sorry, x plus delta x squared, just like it was a 5 there, right? Or a 2. And then I still have minus 1. Now I'm going to go minus. So I'm going to go minus, be careful that you put the back part in parentheses, minus this guy. What is this guy? It's just f of x, see? Or f of x. I can replace it with this. X squared minus 1. Probably the biggest mistake and most often mistake people make is forgetting to put this in parentheses, because that minus goes to the whole thing behind it. So literally, I am plugging in x plus delta x there, and I'm just recopying this here over delta x. I didn't even change the bottom. And now it's just a distribute out. Remember, if I gave you one of these problems on the quiz for limits, all you would do is FOIL stuff out and see what happens, right? I guess I should really, technically, I should plug in a 0 and see what happens. You get 0 over 0. Spoiler alert. So let me FOIL this out. What do you get when you do x plus delta x times x plus delta x? I know some of you hate when there's all sorts of letters here. You got to get used to it. You have to get used to it. This will happen in every problem. So basically, when I see this thing squared, that's my hardest part of this problem. I can do minus 1, and I can distribute my negative. No big deal. But it's this one that I don't want to mess up. You are going to do this so many times. Please get used to it. You got first times first, which is x squared. You got outer, which is x delta x. I know, doesn't look right, but it is. You got inner, which is, don't say delta x, x. If I already started this, I want to do it again, same order, x delta x. And last times last is delta x squared. Now I still got this minus 1, I still got minus x squared. To be good at these, you have to be good at keeping track of your stuff. You got to keep it together. All right, let me finish this guy up. Okay, so I'm going to combine like terms. One thing I should notice is this x squared has a minus x squared and they cancel. This minus 1 has a plus 1 and they cancel. That should happen every time. This stuff at the back should always cancel with something in the problem. Or else, you know what happened? You done messed up. You must have FOILed wrong if stuff doesn't cancel. Now, if I have x delta x plus an x delta x, that makes 2 of them. I think we did this problem in the limit. I just didn't tell you what we were doing. You get to this point, and I'm almost done. I just need to simplify. Remember how my whole goal is to get stuff to cancel off so it's not 0 over 0? Well, if you notice, everything on top has at least one delta x in it, and the bottom of it is delta x. You can cancel off one delta x from each term. Okay, I can cancel off a delta x on bottom, I can cancel off one of these, and I can cancel off one of these. And we're finally to the point where I will be able to plug in for delta x. Not x, be careful. Put the 0 in, not for this. You're putting the 0 in for here. So, boom. So this problem becomes 2x plus 0, also known as 2x. Now the final answer, if my original guy started off as f of x, then my end answer is its derivative, also known as f prime of x. And that should show you the slope of any point on this line is that equation. Any point at all. Okay? So if I want to know what's the slope when x is 20, I put a 20 in here. Slope is 40. If I want to know what the slope of this guy is at negative 3, I put a negative 3 in here. And it's a negative 6 slope. So kind of crazy. All right, I'll come back in another video and do a couple more quicker examples.